Welcome back, everyone. Today we are going to take a look at fonts and rendering GUI labels. I was going to wait until next week to do this episode, but I decided to go ahead and do it today because I've got a little bit of free time. And next week we will go into GUI skins and drawing boxes. So one thing that I wanted to do last week or last episode, not even last week, was I was going to add in alpha because right now I didn't have it implemented and I was going to do it last episode and just completely forgot. The background you can see is black, but it's supposed to be clear. So to do that, all it is GL and come on. GL enable and GL blend. And then we need one more, which is GL blend font and GL source alpha GL 1 minus source alpha. And that's all it is. So now if we run it, now it's clear in the back. So, and then I put that right in the core class between initializing GUI and checking if the window is closed, or checking if it's open. So what I need to do is, first, I need to start the font class. The font class is kind of a pain, but shouldn't be too miserable. Alright, so in the GUI package, create a new class, and I'll call it font. And I'm putting it in the GUI package just because the only time we use font is in GUI, so, well, why wouldn't you put it in the GUI package? So most of the things that we're going to be using is going to be GL11. So first let's go ahead and import that. So lightweight Java game library dot OpenGL dot GL11 star. Alright, so that sets that up. Now what we need to do is create some of the variables that we're going to be using. So like always, we need an ID. So do font ID. Yeah, font ID. And then next we need the buffered image. So do private buffered image, and let's call it buffered image. Go ahead and import that. Now what we need is the image size, which I have not created this class yet. I don't think I have, at least. The vector2 class. No, I have not created it, which we will do in just a minute. So, oh, I have created it. I just created it behind the scenes, that's all. Alright, I'll just go ahead and show you. Vector2 is super simple. It's just x, y, and then a constructor that sets x and y. There's no math in it yet, there's no nothing. So if you just want to go ahead and type that up, super easy. Only takes a few seconds. And then we just toss that out. So then we have vector 2 image size. Next, we need the AWT font that we're going to be using. So go private java.awt.font font. And now we need font matrix or font metrics. Font metrics is extremely important because it has all the information that we need to get to be able to render this font. And of course we need an iterator because we're going to be doing some loops. So now we need a glyph class. Glyph class is going to be pretty simple as well. It's yeah, we'll stick it in GUI too. Why not? Class, call it glyph. This is going to be our character information for each character on a font texture. All it is public float x, public float y, public float width, and public float height, public float scale x, and public float scale y. So x, y, w, and h is UV coordinates, and scale x and scale y is the actual size, like in pixel space. And then create a constructor, so public glyph, float x, float y, float w, float h, float sx, float sy. We'll go what this dot x equals x, this dot y equals y, and I'm sure you guys know how to set up a constructor. And then scale x equals sx, scale y equals sy. Oh, come on. And that's it for the glyph class. It's just going to hold information so that we can render it. And that's it. Alright. So, now what we need is we need a list of glyphs inside of a hash map. This way we can access the hash map and get whatever character information we need. So we need private map, and it's going to be, pretty sure it's character. I don't know, we'll see in just a second. Glyph, we'll name it chars equals new hash map, character, and glyph. Yes. Import these. And that should be all the variables that we need. So let's go ahead and set up a constructor for whenever we create a font. So we need public font, and we're going to pass in a string name, float size. So we need the name of the font and the size that it's going to be. So we're going to say font equals java.awt.font.createFont. And then I think we're going to use, yeah, so whenever we create the font, I'm going to pass in java.awt.true now. It's like this. True type underscore font. And then did I do that right? Syntax error. I'll get to that in just a second. Now we need a file to pass into it. So we're going to say new file. We have not set this folder up yet. Resources, we'll have a font folder. And then plus the name plus dot ttf. What? Yeah. Why are you whining at me? Oh. Surround with try-catch. So this is going to need a try-catch just in case it could not create the font. And I'm just kind of tidying this up a little bit just so it doesn't look like turd. Because I got to stare at it for a few. Alright. So, after we try to create the font, then we're going to call a function called generateFont, which we will get to that in just a minute. Now we also need another constructor. This constructor will take in an AWT font. So, say public font, then java.awt.font. The reason for this is because inside of our GUI class, for our editor, we are going, or for GUI in general, to start out with, and for the editor, we're going to use the default font for your system. And that way we can just pass it in there and then create it. So say this dot font equals font, and then call generate font. So now we have that done. Now we can create the generate font class. So go down here, call private void this time, say generate font. Now we got to do some of the configuration crap. Now this can be a little annoying, but when can't it? So let's go ahead and dive into it, I guess. Go graphics, configuration, yeah, call it, yeah, GC equals graphics environment dot get local graph environment dot get default screen device. Oh, I didn't mean to close that yet. And then we need to get default configuration. All right, that's one stupid thing down. Now on to the next. Need to import this. All right, below it, we need to create a graphics thing. So say graphics equals gc dot create compatible. We'll do 1, 1, and then we need transparency. Transparency dot translucent dot create graphics. And somehow I'm just like adding on extra stuff. And import graphics 2D. Now we can set the font in there. So we can say graphics dot set font and then pass in the font that we stored above. Now we're going to set the font metrics. So font metrics equals graphics dot get font metrics. I don't need that. Get font metrics. Oh, now we can set the image size. A lot of people get the size of all the characters and do all this math nonsense, but for me personally, I use power of 2, and I just use a resolution that, you know, is perfectly fine, which is 1024 by 1024. It's a very common size. So do new vector 2, and then we can call in or pass in 1024 by 1024. So that will create a vector 2 of 1024. And now on to buffered image stuff. Alright, so buffered image equals graphics dot get device configuration dot create compatible. Now all this stuff. Alright, so I'm going to cast it to an int because, oh, stupid. I've got to cast it to an int because our vector2 is using floats. And the reason why we use floats in a vector instead of integers like what you see other people using is because, well, you can always just cast it as you need it. And half the time you're using floats and not integers, or more than half the time if you're me. So imagesize.x, and then we need an integer of imagesize.y, and then transparency dot translucent. And I believe that's it for buffered image. So now we need to set the ID. So now we can go font ID equals GL gen textures, and that's going to get me a textures ID for the font. So now we need to just enable the texture stuff. So we'll do GL enable GL texture 2D, which we did all this stuff before, so it's not going to be anything new. And we're going to bind it. So GL bind texture, GL texture 2D, and then font ID. And then we set the texture GL texture 2D. 0. I know we're going to be using RGBa. And then we are going to pass in the size. So image size dot x, once again, casting to an integer. And yes, casting to an integer. And image size dot y 0. And we're going to be using RGBa again. RGBa. And we need GL unsigned byte, like we were doing before. Why is that not coming up? Oh. And we're going to call something called generate image. I may change the name, but as of right now, we'll just call it generate image. So now we set the texture parameters. GL text parameter. So redundant. Which I guess I could have just cheated and typed in the same stuff we had on in the image class. but whatever. All right, we're going to be using GL linear. Why are you not? Oh, because I forgot an I there. So we'll copy that, paste another one below, and we're going to change this to mag, just like we did before. Mag. Oh, you're still just complaining about generate image. All right, well, fine then, since you're complaining about it. So let's go ahead and create the generate image. Is that what I called it? Yeah. Private. I'm going to return a byte buffer. Call it generate image. So this is going to generate the image and actually paint it onto a texture and create the byte buffer and return it, or paint it on to the graphics, I should say. So inside of here, since I just mentioned it, might as well do graphics immediately. We'll call it G this time. Pass it to graphics 2D and say buffered image dot get graphics, and that will grab our graphics. We'll set the font in there. Set font and font. Now we need to turn text anti-aliasing on. So we need to set the rendering hint for the graphics component. So it's g.set rendering. I want hint. There. So set rendering hint. Rendering hints dot key text anti-aliasing. And the hint value will be rendering hints dot value text anti-alias I'm spelling that wrong. Okay. And on. Yes. So that will turn anti-aliasing on for our text. I mean, you can always add a like if you really wanted to, you can just add in a parameter here that, you know, will turn on or off anti-aliasing if you want it or not. But we're pretty much always going to be using anti-alias for font, at least. So did I just not import that or something? Yeah. So we'll break this down into another thing. So we'll say draw characters and then pass in the graphics component. That way we could just create an entirely new function that actually draws the character. And might as well create a new function and just return this just so it gets rid of this error. We'll just call CreateBuffer. We'll just create a bytebuffer down below. So now we can draw the characters onto the screen. And this method, it really isn't too bad at all. It's pretty easy to understand. It basically, we're going to take all the characters that we can and draw them onto this graphics component. And while we're drawing it, we're going to check the size and just like if the character is way over here and say this is the picture size, it'll drop back over here. So it'll just go like this. And that's how some of our GUI labels are going to be later on down the road too, is we're going to have, it's going to scoot over. So you can either have it where it stops right here, or whenever it gets over here, it'll come back down here. And you'll actually see how this is going to work in this function right here. So what we need is, we need a temporary x variable, which we'll just set it as 0. A temporary y variable, set to 0. Now we need to get the height of the character. So say float h equals cassette to float, and grab font metrics dot get max ascent. And then we need to add font metrics dot get max descent. The hell? Oh, I didn't even know that was a different function. Okay. So now we have our temporary x variable, our temporary y variable, and our height for the height for the letters, which all the letters are going to have the same height. And you'll see all this come into play. But this is basically where we're drawing at. So we'll start out at 0, 0, so over here. And then we'll increase the temporary x, and then once we get to the edge, we'll drop temp x back to 0, so we're going to draw back over here, and then it's going to drop it down the height of the character. So the easiest way to do this is to just loop through all these characters and lower than 256, because there's 256 characters, and I++. And this is where our iterator variables come in, this function and this function right here. So the reason why we're starting at 32 is because all of our stupid characters that really aren't drawing characters are before 32. But you also have one that is 127. So to do that, we need to skip 127. So if I equals 127, we want to continue, which will just skip over 127 and go on to 128. All right, so now we need to grab the character of that, which is really simple. It's just char C and then cast the iterated variable or the iterator to a character. And then that's the character that we need. And then get the character width. So float char width equals font metrics dot char width, and then pass in the C.
Daddy, is snack time already?
Alright, sorry about that. My son wants a snack. So I will try to rush this along and I will go in and get him a snack. Alright, so that gets the character width of the character that we're on. So now we need an advance. I will actually tell you what an advance is. An advance is not the advance that you would imagine. Like if you're familiar with font metrics has an advance, and it gives you the advance whenever you get the char width. Well, we don't want that. We want something extra. And the reason for that is because there is the way that they have it set up. I have never been able to, like, I've done this a million times, and for some reason, no matter what math I'm throwing at it, there's always leftovers from the next character onto the the character that we're on. So say an I is right here and there's a J right here, you'll see the corner of the J right here. So what we're going to do is we're going to just add some padding. We're going to add 5, which is pretty good padding, in between each of these characters so that that does not happen. And after we're all done with this, I will actually show you what that looks like if you do not add that padding. So now that we have an advance, we need to check if tempx plus advance is greater than imagesize.x. So if the character that we're currently trying to render is going to be outside of the screen, then we want to drop tempx to 0 and increase tempy by 1. And then we can just multiply the temp y by the size of the character. And this is what I was describing to you earlier. This is how you add like a wrap method. You just drop it like that and then it wraps it around the screen. It's really easy. So now we need to put the glyph inside of our hash map. I name that chars. Okay. So I need to do chars.put and then pass in the character, and then we're going to call a right? Yeah. That's right. A new glyph. So what that's going to be is tempx divided by imagesize.x. Because remember how I said before, this is the x position of the UV. So we take the current position that we're drawing at and compare it to the image width, and it will give us the position and UV coordinates. So then we also do it in on the Y, which I think it's a little bit different actually. I think it's temp Y times H and then divided by image size dot Y. And that should give us the value that we need there. So that'll give us our Y position. Yeah, temp Y times H. So, you know, temp Y is right here added if we drop down. So then we take the size of each character and multiply it by temp Y. And then we divide it by the image height. So now we need to get the size of the character in UV coordinates. So that is char width divided by image size dot x, and then get the height in UV coordinates. So h divided by image size dot y, and then we'll just pass in the character width. So char width and pass in h for height. All right, all looks good. All right, so now we created the glyph and we passed it into our chars variable. So then anytime we want to call it, we can actually just like tell it what character we're rendering, and it'll give us that glyph information. So now we need to draw it onto the graphics. So we'll say g.drawString, and we have to do string.value of, and then pass in C, because you can't, you know, it's not g.drawCharacter, it's g.drawString, so it has to be in a string. Or you can do C plus and then two parentheses, whichever, doesn't really matter. And then for the X, I'm going to pass in temp X, and for the Y, we want to get the max ascent plus where we're currently at on the Y. So font metrics dot get max ascent, and then add it to h times temp y. That's correct, right? Yep. Okay. So then that will draw the character onto the graphics. And then we can say temp x plus equals advance. And that's it for that function. I mean, like I said, it's not too bad. It's definitely not the worst one. So now we need to this function right here, CreateBuffer. So we need to grab a bytebuffer from this. Right? Yeah. So we'll do private bytebuffer CreateBuffer. Alright, so let's do some casting. Because we need the width, the height, and the pixels for the buffer. So we'll say int w equals int image size dot x, int h for height is is cast to int image size dot y. And we need pixel, the array of pixels, which is pixels equals new int, and then pass in our w times h. So then that will create an array of integers of size, width times height. Oh, right there. Okay, now we need to set some of this data. So, buffered image that we created above, we're going to get the RGB, do 0 and 0, width, height, to pass in the pixels, 0, W. Sorry I'm not explaining that anymore, but there's just so much to explain on there and so little time. Now we need to directly allocate information for the byte buffer. So we need to create a byte buffer, and this will be the buffer that will be returning equals byte buffer dot allocate, do direct w times h times 4, because there's 4 values and a color. Now you have RGBa. So do for I equals 0. Here's our other loop for I. It's lower than pixels dot length and I plus plus. Ooh, now the really dumb stuff. Alright, so now we need to put stuff into the byte buffer. So we'll do buffer.put. Gotta cast this to byte. And should be that. Pass in pixels I for our current iteration. And red is 16. I think, well, yeah. Yeah, because alpha is 24. And 0xff. Alright, so right here we are putting in our red value. And actually, let me just cheat. I don't want to type all this over again. Alright. So, what we're going to do is we're going to change this 16 to an 8. And here, can actually remove that for the red. And this one is 24. And that's for the alpha. So, alpha, scoot that over. RG. And this is for blue. So then that passes in all that data. And of course, like every buffer, you need to flip it. And then return this byte buffer. Finally, gets rid of that stupid error, but of course I'm getting another one somewhere else. GL text image 2D. just in case you had that same error. All right. So now, of course, let's get some returns since we've got a lot of private stuff in here. And we've got it private because we don't need to change this outside of this class. So we'll return the font ID. And then we also need a way to get our glyph map. Say get characters. And it's going to just return chars. And we need to do stringwhip too. This will be the really big important thing later on down the road. Whenever we get to auto correcting like sizes and stuff like that, we will need that. We will return font metrics dot string width and then pass in the string. And that is it. That should be the end of the font class. Now we can move on to the GUI. And this will be the rendering part of it. So, in GUI, we need to have something that hold on just a second. Where are you? Yeah, right here. I'll put this unbind at the bottom. There we go. Okay. So here will be our label class. So we'll do public static void label. We will need a string and a yeah, why not? We'll just go ahead and do a rect. All right. So now that we've got that, we need to be able to get the information from the font class. So, sorry, I'm kind of procrastinating a little. What did we call it? Get characters. So we do chars equals come on now. Let's just do this. So we will get the characters. I don't. Hold on just a second. I'm completely lost. Okay, let's see what I was doing wrong now. Alright. I need to create some variables first. because I don't want to have so many variables inside of this label class. So we'll go ahead and cache some of these. And this is the more important stuff for the GUI. So, need an iterator. So we're going to be using iterators a lot in here. Now we need a an array of characters? Yeah. So private static char array, we'll call it C. And like before, we need a temporary x value. So x temp. And just like before, we need a text color. That way we can change this at any point in time from outside of the script. We'll originally set the text color to color.black. So that'll be default. We could change it at any time so we can have multiple colors of multiple different labels. I mean, if we wanted to, we can even get as far as colorizing individual letters if we actually wanted to. Okay, so now we need a font. So static font. This is going to be the default font. We may change this later, but for now, this will be our default font for the editor. And what we're going to do is we're not going to need any resources folder or anything like that. What we're going to do is get the default font on your machine. So font equals new font, and we created that that constructor that will take in an AWT font. And for now, I'll use Times Roman and do a plain AWT plain, and we'll make this extra large. So I'll do 64. So that'll be a pretty. What am I doing there? So that'll be a pretty big font. Create class AWT font. Oh, it's AWT dot font. Oh, come on, dummy. Just do it. Oh, it's because I did that. There we go. Just got my marker screwed up. So that will create a new Java AWT font. We'll pass it into our font class, and it will do its magic. So now we can actually do the label, because now we actually have a font created. And that's what was screwing with me before. I was thinking about what in the world the font was going to do. So first thing we need to do is we need to bind this font. So we'll do GL bind texture, GL texture 2D, and call font.id to get the ID. So that will bind our font texture. So now we can just, if we wanted to, we could just render the whole font image just like we would draw texture. So then we need to, so now we can actually get the hash map. So I believe it was a map of characters and glyph. Glyph. Chars equals font dot get characters. So that will get our font glyphs. And you know what? I don't want to use a rect. I'm just going to use a vector 2. And this will be our just, no, not vector 2. Do 2 floats. Float y, there. So this will just be our straight up draw. We don't have to worry about boxes or cutting off or any of that stuff. It will just render it no matter what, where it's supposed to be. Okay, so now we need to set xtemp. So xtemp equals x. Yes. And then set the character array. So text.to, did I, oh. Yeah, let's, just so I don't keep on typing that. So to char array. Okay, so that'll get a character array out of the text that we send. And now we need to set the material color, which will be the text color. So whatever our text color will be, we'll just pass it into the shader. So we'll call shader dot set uniform and material color, and then pass in text color. Char array loop. So now we can loop the character array. Say c dot length I plus plus. So this will be for every character in our string. So for every character in our string, we need to get the glyph of the of that character. Say chars dot get and then ci. So that gets our glyph. And let's see here. Need offset, pixel scale, and screen position. So I've already got color. Okay. So I'll go ahead and do the screen position. So do shader dot set uniform screen path, and all we're going to do here is we're going to pass in xtemp and y. And then the next one we need is the offset. So it'll be shader dot set uniform offset, and this will be the UV offset. So we'll call it R. So R dot X, and go R dot Y, and R dot W for width, and R dot H for height. So now offset is created. And do pixel scale next. So now I'll set the pixel scale to scale X and scale Y of the glyph. So the actual pixel scale. And now you probably know why I called it pixel scale in the shader. Is because it's the whenever we pass it in, if we say we want it 8 units, it's going to be 8 pixels. So we'll do R dot scale X and then R dot scale Y. And then after we set all this stuff, we need to render it. So do mesh dot render. And then we need to change the X position. So it'll render one here, and then it'll take the scale, and it'll render one here, and so on and so on. We'll just say X10 plus equals R dot scale X. And I believe that's it. Pretty sure that's it. I mean, it's not going to do anything right now, but I'm just making sure. Didn't mess anything up. Alright, so in the main, right now we're drawing some textures here. Try to do GUI dot label, and I'll say this is a test. And then for the X position, I'm going to put, let's say 50. That's rendering at 100, so 250. Render it at 300. 300 on the Y, just so that it's below this texture right here on the screen. And it should be fairly big. And what in the world is that? Huh. Never seen that before. Let's see if I can figure out what in the world is going on here. Give me just a moment. I'm going to look through this code and see what's going on. Okay, so stupid me. Whenever I type this first line, I put a time symbol right here, an asterisk. So whenever I duplicated it, it kept on putting it there, and I never realized it was there. So that is supposed to be an and symbol. Oh, stupid. But we got tons of stuff done on this font. So now if we run it, now we will see it rendering. So let me show you this really quick. Where is that? I put that advance at? Right here. All right. So if we do not add that 5 padding that I was talking about earlier, check this out. Like here with the eyes that I was telling you about. The J is over here, and for some reason it is putting this J over here, even though it's supposed to be rendering character and then separating it by, or it's supposed to draw the character in its bounds and then move the X temp over and then draw the other bounds over here. Well, it's not doing that for some reason. So what it does is it draws it in the wrong spot. I don't know why. I mean, like I said, I've been using this same system for years now, and I have never found the solution to it, or like figure out why it's doing that at least. So if you guys know why that is, then by all means let me know, because that would be a huge help. But in the meantime, I mean, it's not really a big problem. All we do is just add some fluff, add some edging on there. So now it's separated enough where you don't have that issue at all. And if we had font in here, we have it set up so that we can also just create a font folder and drop whatever font we need in there, and then call this constructor right here. We can also do that as well, and it will also do it. So that is it. Rendering font like a pro now. Well, like an amateur, but we will eventually get to it where we'll do some crazy stuff with some fonts. Like if we have bounds up here, say it can't go past this bounds, it will cut it off. It will automatically adjust the UV to rectangles, so it will only draw inside of there, and we will do some wrapping and all kinds of crazy stuff with some font. So look for that in the future. But in the meantime, next episode we will work on GUI skins, and we will see if there's enough time to draw some boxes or windows or whatever we decide to render at that time. So I guess I will see you on the next episode, and thanks for watching.